Why, hello everyone. Happy St. Patrick's Day and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of our grad students who works at the Planetarium, and I will let her introduce herself.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight we are continuing our celebration of Women's History Month with History of Astronomy, where we will take a look at some of the contributions that women have made to the field of astronomy, many of which are often overlooked, or men who later made those observations were then given the credit, even though they didn't discover it first. And so Lindsay is going to be leading that show for us tonight. Before we jump into that, if you do have any questions throughout the show, feel free to leave them down in the comments. I will be keeping an eye on that and we'll let Lindsay know as questions come up. We'll also have time at the end to answer questions as well. So with that, I will hand it over to Lindsay.
Thanks. So tonight is going to be, again, mostly, history of astronomy. Next week is when we're going to get into some more recent women who are a part of, NASA and the rovers and some recent astronomers. So these are just kind of the women kind of before the year 2000, which was 20 years ago now. Okay. So we are going to start in the 2nd century BC with a woman named Nietzsche. Um, so she had such great knowledge of the moon, people thought she was a sorceress. So because she knew the patterns of the moon so well, and she figured out and could calculate when lunar eclipses were going to happen, she could tell people, like, the moon is going to like turn red now, or is going to disappear now, or whatever. And so they thought that she was a sorceress because she had that knowledge. I also recently found out she had a few other women that were with her, doing more astrology than astronomy. But because they knew so much about predicting the moon cycles and things like that, they were called witches of Thalassus. Okay, hopping ahead to the 4th century AD. So this is in ancient Greece. This woman is Hypatia. She was actually a professor of astronomy in ancient Greece. She also taught mathematics and astronomy at a local school and taught astronomy to the public there in ancient Greece. Hopping up to the 10th century. So we have a Muslim woman, Miriam al-Astrolabi, and she helped manufacture astrolabes. She didn't invent them, but her family did, and so she just helped kind of improve upon the astrolabe. And this tool over here on the right side, that's what an astrolabe looks like. And so she kind of helped make improvements and stuff to the astrolabe. Now to the 16th century. Oops. Okay, so Sophia Brahe was the sister of somebody you may have heard about, Tycho Brahe. If you've learned anything about astronomy, you probably have heard about Tycho. He has some pretty interesting things that happened to him. But he and his sister Sophia were working mostly at the Danish Royal Observatory, and they were making all sorts of astronomical observations. But none of those observations are ever attributed to Sophia. Their observations led to the discovery of this supernova right here, but instead of calling it the Brahe supernova so that it could cover both Sophia and Tycho, they just call it the Tycho Brahe after her brother. So this is definitely a case where a lot of people don't even know that Sophia did work with her brother because he is known so much better than she is. All right, the 17th century, we have Maria Kunitz. She authored a book that included new solutions for determining the positions of planets. Elizabeth Hevelius, she is known as the mother of moon charts. Her husband was also an astronomer, Johannes Hevelius, and they cataloged more than 1,500 stars. And this is a sketch of her, Elizabeth, and then this is um, one of her moon charts. Okay, the 18th century, Nicole Renee Lapaute. She was a French astronomer who predicted the return of Halley's Comet. So that is this picture right down here. We, now know that it comes back at a very regular um, period. And so she was able to predict when it was going to return. Marie Jeanne Emily Le Francais de Lalande. She established a catalog of 10,000 stars. I feel like France was the place to be in the 18th century if you wanted to be a female astronomer. Carolyn Herschel, she was in England though. You may also, if you've learned anything about astronomy, you may have learned about her brother, William Herschel. He is credited with discovering the planet Uranus, but actually it was both of them. And they both discovered several comets. For the most part, any comet that you see have Herschel as part of its name, it's actually for Carolyn Herschel. It's one that Carolyn Herschel found, not William Herschel. They also created a new star map, and she was the first woman to get paid to do astronomy. Princess Charlotte of Saxe-Meningen, not sure if I'm doing that right, but she also is from France. She participated in observations with the astronomers in the French court, and she attended the first European Astronomy Congress in 1798. All right, heading into the 19th century, this woman is also from France, Emily du Châtelet. So she translated Newton's Principia into French. So Isaac Newton, he wrote this book called the Principia, and it has in it what we now kind of refer to as Newton's laws. And so she translated that book, published by Newton, into French. She also added some of her own notes and calculations and things too. Maria Mitchell, she discovered a comet in 1847, and she won a gold medal prize from the King of Denmark for her discovery. Agnes Mary Clerk, she published a book called The Popular History of Astronomy during the 19th century. Mary Adela Blagg, she observed the moon and created a list of all of the lunar features. And actually, the system that she created for naming things on the moons, like the craters and the Mare regions and the highlands and things like that, we still use her system for naming things on our moon. Okay, so now we're going to talk about the Harvard Observatory. This is from about 1877 to 1919, so a little bit in those 2 centuries. And there were a group of women here at the time that were human computers. So the men would be allowed to use the telescopes at night to take pictures. They weren't pictures like we have now. They were actually pictures on glass plates back at this time. And so the women weren't allowed to even look at the telescope or touch it or be in the observatory, but they did analyze all of those glass plates. I think that's probably a little more difficult than taking pictures. But anyway, Edward Pickering was the guy that was kind of in charge of all of these women. And sometimes they're referred to as Pickering's harem. But these women actually made a ton of discoveries for themselves. So they weren't just, computing and calculating. So this is Antonia Mari. She published an early catalog of stellar spectra. So spectra, so if you look at like a prism, um, and light is coming through the window, going through a prism. That prism separates light out into the rainbow. So we kind of have a similar contraption on telescopes that separates the starlight out into a full rainbow. That's called its spectra. So now we are able to, have nice, pretty rainbow colored spectra to help us observe stars. But back then they were black and white. I can't even imagine trying to analyze spectra in black and white. So this is kind of what she would be seeing, and this is how she cataloged many stars and their spectra. Wilhelmina Fleming, she cataloged thousands of stars and helped create a classification system. She also discovered the Horsehead Nebula, which is this nebula right in the middle here. Henrietta Leavitt, she discovered Cepheid variable stars and that they could be used to measure distances. So here on the right side, you can kind of see an animation where there's the star getting brighter and dimmer. There are several different types of variable stars and different reasons why stars can vary in brightness like this. Henrietta Leavitt looked specifically at Cepheid variable stars, and she found out that they always reach the same luminosity. And so how bright then they look to us from Earth, we can determine how far away they are. So Cepheid variable stars that are farther away from us are going to look less bright than Cepheid variables that are closer to us. And this was really significant because at the time, we actually didn't have a way to measure to other galaxies. So at this time, there were kind of two fields of thought about these galaxies up in the sky. They actually weren't called galaxies yet. They were called spiral nebulae. And so there was one pool of thought that they were inside the Milky Way galaxy and they were just spiral nebulae. And then there was another thought that these were actually separate galaxies outside the Milky Way, but we had no way of measuring to them yet because they were too far away. So since Henrietta Leavitt discovered this Cepheid variable stars, we were then able to measure to the galaxies and find out that they were in fact completely different galaxies than the Milky Way and very far away from us. And this helped Edwin Hubble, who you probably have heard of because there's this thing, in space called the Hubble Space Telescope. And he ended up kind of helping make that discovery and also used Henrietta's discovery to help find out that the universe is expanding. So without Henrietta Leavitt making this discovery, Edwin Hubble would not have been able to make his discovery about galaxies. Annie Jump Cannon, she established a stellar classification system that we still use today. So we have these big blue, hot, really, really, really hot stars. They're O-type stars. And then we get smaller and also the temperature gets cooler. We go down to B, A, F, G, K, and M. It used to be all of the alphabet from A to O, but to make it a little easier on everybody, she ended up cutting down the number of stellar classifications to just these ones. So Cecilia Payne Kapashkin, she also was just studying spectra, and she was just studying specifically the spectra of our sun. So here on the right is a beautiful stellar spectra for the sun that we have been able to take with our colored cameras. But again, these were in black and white. And so she was figuring out the spectra of the sun with these black and white plates. So spectra can help us figure out the composition of stars, actually. So if we see a particular line in the spectrum, that line actually corresponds to a specific element. And all elements have different lines on the spectra. And so she was able, because of this, we are able to figure out compositions of stars, but she was also able to find the composition of the sun. Kind of a big deal. And you probably haven't heard of Cecilia Payne, unfortunately. Um, her She wasn't really believed at first. So before this discovery, it was thought that the sun was made up of the same types of stuff that we have here on Earth because they were made out of the same kind of part of the nebula. But in fact, she found that the sun is actually mostly hydrogen with some helium. And again, she wasn't believed at first until a man found out the same thing, and then she was believed. But still, nobody knows her, unfortunately. Muriel Mussel's Seifert, she discovered the Ring Nebula. That's one of my favorite things actually to look at with a telescope. All right, heading into the 20th century. So now we're getting away from all those women who did amazing work at the Harvard Observatory. We have Elizabeth Alexander. So she worked with radar technology during World War II, and it led her to become a pioneer in radio astronomy. Another radio astronomer is Ruby Payne Scott. She was from Australia, and she studied radio physics, and she was the first female radio astronomer. Priscilla Fairfield Bach. She authored papers on clusters and star magnitudes with her husband. So over here, you can see Priscilla and her husband. This star cluster right here is M13. It is the Great Cluster in the Hercules constellation. Again, one of my favorite things to look at through a telescope. Okay, so Eva Einart Rolfs, she also studied variable stars like Henrietta Leavitt. So again, you can see how these variable stars vary in the brightness. And again, that can be for several different reasons. It could be that the actual star is changing in luminosity. It could also be that there's another star kind of passing in front of that star that makes it change in luminosity. So there's a few different ways that can happen. Elizabeth Roemer, she discovered two asteroids and a moon of Jupiter uh, named Themisto, and she collected data about the magnitude of the nuclei. So this is Themisto right here. So this is kind of how they find moons and also comets or asteroids. You take two pictures at two different times of the same part of the sky, and whatever is moving is something like a comet or an asteroid or a moon. Because anything that's not moving is just going to be a star, because the stars don't move. They're too far away for us to see they're moving. So this is the Mesto here. And actually, it's so small and difficult to find. It was found by Elizabeth in 1975 first, and then it was lost. And nobody was able to find it again until the year 2000. And that's actually what these pictures are from. Erica Baum-Vitens, she studied convection and stellar atmospheres and realized that UV light is the best way to observe chromospheres of stars. So here in the middle here, I have some views of the sun by the Solar Dynamics Observatory. So on the left here is this kind of tealish bluish. That is the UV light. And then you can see views of the sun in two different wavelengths. And as we watch this video, you can just look for the differences that you can see with these different color filters. So with this bluish, you can see kind of some of the convection cells on the sun a little bit better. But over here, you kind of see some of the bigger structures on the sun. So she helped us find out by looking at the sun and other stars in different wavelengths of color, we can observe different things about the sun and other stars. Okay, Vera Rubin, she discovered dark matter. Only 3 words, but very important. So, dark matter actually has to do with galaxies. So, when we are looking at the velocity of stars orbiting around the center of their galaxy, um, we expect the stars to be at a certain velocity, a certain distance away from the star, just based on laws of physics. So the farther away you get from our central black hole of the galaxy, the slower the stars are going to be. But these stars out in the outer reaches of the galaxies actually were going faster than we thought they should. So, what could be causing this? Possibly matter that we can't see. And that is affecting the velocity of this kind of edges of the spiral galaxy that we can see. So, dark matter is just matter that we can't see and can't observe yet. Carolyn Shoemaker, she once held the record for most comets discovered by an individual. So anytime you see a comet named after Shoemaker, it's named after Caroline or Carolyn. And in fact, one of the comets that she discovered, Shoemaker-Levy 9, crashed into Jupiter's atmosphere. And so, yeah, that was a pretty cool event. And this next astronomer, Rita F. Beebe, she was an expert on the atmospheres of the gas giant planets. So she, when this happened, she was one of the people, one of the experts checking out Jupiter's atmosphere and kind of what kind of changes and things were going to happen when the comet hit Jupiter's atmosphere. Jocelyn Bell Burnell discovered the first radio pulsars. Nancy Roman, she was one of the first female executives at NASA. She also helped kind of start the ball rolling with the Hubble Space Telescope. So she started with kind of some of the initial planning that was going on. And Margaret Burbridge also helped with the Hubble Space Telescope. She also showed that all of the elements, except for the very lightest elements, are produced by nuclear processes inside stars. So during the Big Bang, when the universe was created, mostly the universe was only hydrogen and helium, maybe a little bit of lithium, but a very tiny amount. So every other element that you know of, uh, carbon, uh, lead, etc., some of those were made inside the nuclear processes inside stars. And then elements that are heavier than iron, they were actually all made during supernovas. So we wouldn't have things like, gold and mercury and silver and things if a star had not supernovaed. She also helped develop a spectrograph specifically for the Hubble Space Telescope. And she discovered that the galaxy M82 has a massive black hole at its center. And now we're pretty sure that there are supermassive black holes at the center of every galaxy.
Cool. And that's a good kind of like cliffhanger ending because from there we have some amazing women who are continuing to do work with things like black holes. And this answers the question that we got of leading women astronomers today. And that's actually what our show next week is going to be all about.
So you may have heard about the new image of a black hole that was taken. That code was done by a woman, Katie Bowman. Burchin is a woman that has a galaxy named after herself. Tabitha B, I can't remember her full last name right now, but she has a star name that she found called Tabby Star. So all of these kind of recent discoveries by women that are really awesome. we're going to do next week.
Yeah, absolutely.
And is it this Saturday or next Saturday that is the black holes?
Next Saturday. Yeah. So if you are intrigued by these objects called black holes, the next show in our monthly exploration series, next Saturday is going to be looking in depth at black holes, what they are, how they form, how it is we can see something that doesn't give off light, all sorts of things about it. And I'm really excited for that show. I know it's something we get asked about a lot. So I think it's going to be fun to do a whole show just devoted to black holes.
And I will be there. And actually, part of the research I'm doing for my master's is about the mass of black holes in galaxies. So, looking at kind of smaller galaxies and if they also have smaller black holes at the center, like the massive galaxies have massive black holes at the center.
And maybe if there's interest, we could even do a show where you can talk about your research, because I think it's cool, but
Yeah.
I'm maybe a little biased. All right, awesome. So yeah, those are just, I would say not even all, just some of the contributions made to astronomy. There's been some just incredible work. I am in awe of the women who worked at the Harvard Observatory. Like studying those spectra by hand, classifying
No
tens
calculate,
of thousands
like,
of them. And to kind of get a reference, like when we talk about classifying spectra, you saw that there were those kind of dark lines in the spectra of the images we showed. And so what you have to do is match those lines up with a library of kind of known spectra of the elements. So what hydrogen would look like, helium, lithium, beryllium, all of that. And you have to go in and match them up to figure out what lines go with what elements, and that tells you the composition of the object. And of course, today we have computers to do this that can just go through and match things. But what these women were doing for tens of thousands of stars was going in by hand and matching these by eye. Like, it is amazing, just the sheer number of classifications they did. Because I think it was Annie, I think it was Annie Jump Cannon who did like a couple 10,000
yeah.
of these. Yeah, it's crazy. All without computers, all by eye. Like I can't imagine doing that. And to be thought that they weren't considered worthy of actually using the telescopes themselves when, yeah, they were by far doing the difficult work. And then the guys just published their results as if they did it. Sorry, I may be a little bitter still about some of this.
It still happens. So it's
It
something we need to,
does.
unfortunately.
Yeah, it does still happen. All right. Well, I am not seeing any other questions. Got a couple of great presentation, which giving Lindsay all the credit. She does an amazing job with these shows. We will stick around for a few more minutes. If you do have any other questions, now you can leave them in the comments, and we will check to see if any of those come through. And while we do that, let me tell you what we have coming up over the next week.
Okay, I wanted to comment on what you said earlier about how this is not even all of the women in the history of astronomy. I try to add one or two women at least every time I do a history show. So you can always come back and learn about more women the next time I do this.
Absolutely. So on Saturday, we are going to be doing another edition of Ask an Astronomer, where we will be here answering your questions, whatever questions you have. So if you've got anything, you can join us Saturday. We'll also be putting up a post to collect questions earlier in the day as well. Next Wednesday, as we said, we were doing our last in our Women's History Month series for women making history, and this is all about the current women in astronomy. And then, as we also said, next Saturday, we are doing the next series, next show in our exploration series looking at black holes. Now, we are still offering private virtual shows. If you are interested in booking one, you can find information about that at our website. And yeah, we are looking to maybe hopefully start some in-person stuff this summer. We will, of course, keep you updated with that. And then the only other thing is we're going to be doing a kind of scaled back, socially distanced astronomy day this year. And we'll have more information coming about that very soon. That'll be happening in May. But it's still going to be a lot of fun. We'll have cool stuff to hand out, little mini activities that you can do at home to explore astronomy yourself. And yeah, it's going to be fun. But details will be coming soon. All right. All right. I think that is everything. I'm not seeing any more questions. So thank you everyone so much for joining us. Thank you, Lindsay, again for this amazing show. If you liked what you saw tonight, we do host these shows every Wednesday and Saturday at 7 p.m. So definitely come back and see us again. All right, well, have a wonderful evening, everyone, and we will see you next time. Bye.